Okay, let's go ahead and get started. Your first homework assignment is due before class on Monday. And I've already gotten some good questions on the homework. I could tell that some folks have an early start, which is good. The in-class exercise we're going to work on today, I think, further supports what you're going to be asked to do on that homework assignment. But if you do have questions, you can stop by my office. I've got office hours after class today. And you can also send me emails. I do check my message occasionally during the weekend, and I'll do my best to help you out. So just as a reminder, the whole assignment should be a single continuous PDF file with good contrast. It should be clear and sharp. So whether that means using your phone or a flatbed scanner or a lot of copy machines will generate a PDF for you, please make sure that it's legible and turned in before the deadline at 12. Any questions before we start talking about cash flow diagrams? Okay, so remember, this class is about decision making and evaluating options, trying to know, is it better to do one thing or another thing? And in evaluating options, we oftentimes have to kind of break down complicated transactions into some sort of a simpler way of expressing it. So there may be a lengthy word problem that we have to make a diagram of, or there may be a diagram that we turn into a cash flow table. So we're going to kind of like be translating between different ways to summarize financial information. And so we'll rely on having a common understanding of a few terms that relate to money coming into an organization and money going out. So cash inflows have a lot of different names. Sometimes they'll be called revenues or receipt, income. If an organization used to be spending money on something, but then they did some improvement to reduce those expenses, then that also is classified as an inflow. So for example, if there was a warehouse that was poorly insulated and they were spending a lot of money to heat the warehouse, but then they put insulation in the roof and suddenly their heating bill goes down. So here where it says savings generated by projects and activities that flow in, so if you make some sort of a change and your previous expenses have been reduced, then that also can be booked as a cash inflow. Outflows are sometimes known as disbursements, costs, expenses, taxes can be counted as outflows. And so this is just the money that flows out of an organization. And remember that perspective is important. We talked about it on Wednesday, how from the perspective of a borrower, when you're paying interest, that's an outflow. From the perspective of a lender, that same interest is an inflow. So it depends on, in a transaction, whether we are looking at it from one party's point of view or from another. And so always try and read carefully in the problem statement whose point of view you're taking into account. Net cash flow, sometimes we'll call that profit. It's the difference between the inflows and the outflows. So the difference between your revenues and disbursements is how much excess money there is for a project. It can be thought of as the profit that the owners of the project get to keep as a reward for doing some work. Now, the end of period assumption is something that will apply all through the semester, and it's the default assumption. And the end of a period assumption says that we're going to assume that we summarize what happens during a certain period. Maybe it's on a monthly basis. We'll look at all of the expenses and all of the revenues that occur during a monthly basis, but we'll say that they actually come into the organization or go out of the organization at the end of the period. So you can think of it as, maybe you have a light bill that comes in and a heating bill and a water and sewer. You get all these bills, but some people keep them to the end of the month and then pay it all at once. And so they have the bill, but they haven't actually paid it until the end of the period. So we'll apply that same thinking when we are doing calculations related to business opportunities or investments. We'll say that all of the revenue comes in once during a period, and it's at the end of the period, and then all of the costs are the same. So I'll show you how we apply the end of period assumption in just a bit. But why are we going to bother with cash flow diagrams? It's because we can read them more quickly and more easily than word problems. And it's more standardized. Just at a glance, you'll be able to look at a cash flow diagram. Once you get in the habit of it, once you've seen a few of them, then it's going to become really clear what they mean. And so it's just kind of a shorthand way of communicating when money is going out or coming in, how much, and applicable interest rates as well. So here's a word statement, like a word problem or a phrase that's summarizing situation here. So you borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? I mean, that's not too complicated. It only takes you a few seconds to read it, think about it, digest it, but it's even more quick if we just have a diagram that we can put that same information onto. And so when we diagram it, our standard notation is going to be anytime money is coming to you or the organization that is being described, then money that comes in from the perspective of you or the organization being described is on the top side of the figure, and any money that's going out is on the bottom line of the figure. So inflows are arrows that are up, outflows are arrows that are down. So this is how we would summarize that problem statement. And this, just because I'm accustomed to looking at cash flow diagrams, I instantly can look at this picture and in half a second understand which formula I should apply, what it's asking. So this is, you get $10,000 at time 0, meaning the present. An interest rate of 6% applies, and then the question is, how much money do you have to pay as a lump sum in year 5? So the way that I know it's an unknown is the fact that it's a dashed line, and then these question marks here also indicate that the future amount is an unknown. The arrow is down, so that's how much you're going to have to pay. And so these cash flow diagrams are a nice way to summarize what's happening and figure out what we're supposed to be calculating. Any questions so far about the need for cash flow diagrams? All right. There's also, in addition to a standardized approach for up being inflows, down being outflows, there's also labels that we're going to apply, just a standard notation for variables. And so we're going to use the letter I, lowercase I, to represent an interest rate. Now, by the way, the uppercase I means an interest amount. So when it's a lowercase I, we're talking about a percentage, expressed as a percent per year. N is the number of periods that are applicable, and so in this problem statement where it says in parentheses compounded annually, that's telling us that there's one compounding period per year, 5 years is the period, so then N would be 5 in that problem. P is a certain amount of money at time 0 when the transactions begin, and so it says here you borrow $10,000 at 6%. It doesn't explicitly say you borrow $10,000 at year 0, but just by definition, that's the first transaction that's described in this statement. So in our minds, we know that is the 0 point for when measuring time begins. Is when that day that you borrow the $10,000 kind of kicks everything off, and so that is P, the present. F is the amount of money in the future. So how much must be repaid after 5 years? So F is the unknown amount that we'd be trying to calculate in the future. So cash flow diagrams are very useful. This is how we would summarize the problem if we just kind of translated the word problem into variables and their values. So we'd need to find an equation that solves for F given P, I, and N. And I think you've already seen an equation that did that. I think in our prior class meeting we had F equals P times 1 plus I to the N power. So if you want to find out what lump sum future amount is due, it would be the present value multiplied by 1 plus I to the power of N. And the reason why N is as an exponent is that it takes into account the effect of compounding. So we'll have a lot of formulas we use this semester. They can be summarized on a single page, and I'll bring you a printout of the formulas. You can keep it in your 3-ring binder that you're going to use for the course. And then there's also going to be page after page of tables that relates how to find P given F, how to find F given P for different interest rates. So there's a different table for every interest rate, or you can solve it using equations. So I'll give you those in a coming lecture. So these diagrams for estimating cash flows can either be a point estimate, which is where we're saying we believe that the future, in this case, revenue that we're going to receive is $150,000 each year for 6 years. So there's a couple of things we should notice about this. All of the arrows are the same length. So that tells us that's one indicator that the amounts are the same. And then here, where it's saying A, we'll learn more about this in a future class meeting, but what it basically means is it's an annual series. And by definition, an annual series has the same amount repeating every time. So, but in this case, we are trying to predict in the future how much money we're going to get. And you know, we're not fortune tellers. We don't know everything with perfect precision in the future. Sometimes we do our best and we'll just say, let's do these calculations based on the guess that each one of the inflows is $150,000. Another way of dealing with uncertainty is to use a range where we say maybe we bound the minimum value that we expect it could be, the maximum value that we expect it could be. And so this is an illustration of how if we, instead of using a point estimate, if we said we think that the future revenues will be between $135,000 and $150,000, then we could graphically represent it like this, and then maybe what we would do if we wanted to find out what's the present value equivalent of those future revenues is we would find out what's the present value equivalent if it's on the low end of 135. And then we'd separately calculate what's the present value equivalent if it's on the high end. So sometimes we'll calculate across the whole range of possible values, but most of the time we'll just represent it as a point estimate, and then in the back of our minds acknowledge that we don't always know with perfect certainty what the amounts are going to be in the future. So these are two different ways to represent cash flow diagrams. Okay, so now you're hopefully starting to think about what is this cash flow diagram asking you to solve. So this cash flow diagram is asking you to find out for these known values in the future. It's going to be an annual series in years 3 through 9. Every year you get 4,100. If you've got an interest rate that applies of 4%, what is the single lump sum equivalent of those future revenues? So basically what it's saying is, if 4% is the interest rate, how much should you receive today as a lump sum that's economically equivalent to these future payments? So for a cash flow diagram to be complete, it needs to have the labels of P, F, and A, any one of these that apply. So this has a P and an A. F is what we use for a single lump sum value that is on a cash flow diagram by itself. So none of these are F's because they're all the same amount, and it's just simpler for us to represent it as a continuous annual series rather than as a bunch of single individual F values. This 4% interest rate, sometimes you'll hear me call it a discount rate. In a problem like this, an interest rate of 4% is a discount rate because what we're doing to find P is we're taking these future amounts and we're taking them backwards through time and finding out how much are they equivalent to in year 0. So because money in the present is more valuable than money in the future, it doesn't take as much money in the present to be equivalent economically to future dollars. So, for example, in 3 years you get $4,100. If you have to wait 3 years to get $4,100, then today, at time 0, you should be willing to take less than $4,100 because now you can buy more with that money than you can in 3 years. So 4% when you're moving money from the future to the present is a discount rate. And then when we're moving money from the present into the future, we'll call it a compounding interest rate. So this cash flow diagram, a little bit more complicated. There's no unknown on this cash flow diagram, but if we're going to annotate the values, this is an annual series where the arrows are the same length, the amount is the same, and so that's an A. And then each one of these amounts in the future would be considered an F because the amounts are different from year to year. It's also a gradient, which is something that we'll talk about in a few lectures, where if the amount is increasing by a constant value in each subsequent year, then there's a way for us to calculate it called a gradient. So we're going to get into all kind of problem-solving type stuff. Some guidance here is that the arrow doesn't have to be like to the pixel perfectly scaled. I don't expect you to write the arrow length completely consistent with the amount, but generally speaking, it's better if a small arrow is used to represent an amount that's less than a large arrow. So if you've got a cash flow diagram like here, where we've got 5,000, 6,000, 7,000, 8,000, it's a good practice to have the arrow length roughly correspond to the amounts. So you can see that the amounts are getting bigger without even having to look at the label. As far as the interest rate, it doesn't matter if it's above the cash flow diagram or below it or somewhere to the side. It should just be in the proximity to the cash flow diagram so that we can notice what interest rate applies for this time value of money problem. And then anytime there's a value that we're trying to find out the amount of, the unknown, it's best to represent that with a dashed line and then a question mark next to the label. So that's how we'll designate that there's a certain amount that is unknown, which is what we're trying to solve. And this is, you know, like there's some greatest hits of mistakes that students seem to make on exams. And I'll always tell you what those greatest hits are. I'm not going to try and like hide it from you. I want you to learn from the mistakes of the classes that have gone before you. But sometimes, if I make this diagram, you can see it has 18 years on it. That doesn't mean that n is 18 years just because the diagram itself has a certain number of tick marks on it. The n value corresponds to how many years there's something happening with money. It's not necessarily how long the diagram is, but it's how many years actually have an arrow coming from them. So this note here, the length of the cash flow diagram does not tell you n, is related to the fact that we may make this cash flow diagram really long because maybe we'll add additional things to it after another analysis. But for now, n in this problem is 9, because from time 0 to whether there's an unknown future present value we're trying to find, to the end of the cash flow diagram is 9 years. So it doesn't matter that the cash flow diagram has additional tick marks beyond the 9th year. Okay, I have an in-class exercise for you today, just some ways to practice what we've been talking about with cash flow diagrams and translating it from a word problem to a sketch or from the diagram to a table. So let me hand that out to you. Did anybody need a copy that didn't get one? So let's take a look at the solution of the first one. Okay, so it says, draw a sketch including labels to summarize the following. Today you receive $10,000 from the bank, and then starting 1 year from today, you make 4 annual payments to the bank in the amount of $3,300. So you get $10,000. It's a solid line because we know the amount. It's labeled with a P. The line is longer than the other ones because that represents 10,000, whereas the other lines are just 3,300. 4 annual payments to the bank in the amount of $3,300. And so we're labeling it with an A, which means an annual series. It's also called a uniform series. We still label it with an A, even if they're monthly payments. It's just a uniform annual series is what it's called when it's successive with no breaks in between and if the amounts are the same. So you can see the arrow is down, representing that your money is going away from you. You're paying the bank, and the amount's $3,300. So that's the first one. The next one, I'm asking you to draw it from 2 different perspectives. Draw it from your perspective, and then to draw it from the bank's perspective, which will just be like a mirror image of it. So on that one, on problem 2, your perspective, there we go. Your perspective is that a year from now, you are going to save $10,000. That means you're going to deposit it in a bank. So you're depositing $10,000 into a bank at the end of each year for 6 years. So the first year goes from time 0 to time 1. The first year is a period. The number 1 is an instant in time. That tick mark represents the end of the first year and the beginning of the second year. So the first year is from 0 to 1, the end of period assumption. Remember that we talked about that already? The line goes at the end of the first year because of the end of period assumption. So you deposit $10,000 each year for 6 years, and then at the end of the 7th year, you withdraw the balance. The amount is not known. So it's a dashed line because we don't know the amount. It's got a label F equals question mark because it's a future value as a lump sum. And I've made the arrow larger than all of those deposits because we presume that regardless of what the interest rate is, you wouldn't be depositing money in a bank if you're not going to get back more in the future than you're depositing over time. So that's your perspective, but from the bank's perspective, they get money for 6 years and then have to pay it out as a single lump sum. So the bank's perspective is the mirror image of that. There's no calculations with problem 3 related to the time value of money. All we're doing in finding the net cash flow is looking at the inflow minus the outflow amount. So there's no interest rate that's been specified in problem 3, so I'm not asking you to find the present value of any of these. It's just translate the diagram into a table. And you'll get good at this when we start using Excel. By the way, there will be a point in the class where you'll need to basically bring your computer to the lecture, each class meeting, and it should have Microsoft Excel on it. That'll probably be in 2 weeks. I'll let you know the lecture beforehand when you need to start bringing your computer to each class. But for this one, you'll see that there is 1 year, the end of year 6, where the outflow is greater than the net inflow. So we'll have a negative net cash flow for that year. The rest of them are positive. Question 4 is a trick question. I was trying to see if you saw that it says from the bank's perspective. This time I underlined it. In an exam, maybe I'd try and sneak it in there without underlining it. Always got to ask yourself, like, whose perspective are you doing the cash flow diagram from? Because from your perspective, it'll look one way. It's from the bank's perspective, it'll look the other. And this one was the bank's perspective. And then problem 5, we're using this formula to find the future value of a single present amount where it's compounding at I interest rate for n years. And so the cash flow diagram has 10,000 that you're getting at times 0, 5,000 you're getting 1 year from now. How much do you have to pay back to the bank as a single lump sum in year 5? That's economically equivalent if an interest rate of 6% applies. So we do it in two steps. We find out what is the present, what's the future value of the 10,000, where n is 5. And then we find out what is the future equivalent of, that's a typo. That should say 5,000 right there, shouldn't it? Yeah. I think the amount is correct, but instead of writing 10,000, I should have written 5,000 there. So you received 10,000 today, 5,000 in year 1. The sum of the future values, 19,694 and 64 cents. So it would be wrong if you wrote 19,000. It would be less wrong if you said 19,600. On these, where you've got a formula, you should be able to remain accurate to the nearest penny. So that's the expectation when you're using what I'll call the equation method. Later in the semester, when we start using factor tables, you aren't necessarily able to be accurate to the nearest penny. There's going to be some round off with the factor tables. But for the equations, round off to the nearest penny. So any questions about today's in-class exercise? Let's just revisit the announcements before you go your way. Homework 1 is due before class on Monday. All right, have a great weekend.